Functions. Ooh, interesting. Mine is thinking of bodily functions, but that's a whole new discussion. And there is other things. Those of you who are being taught by me will be looking at completing those 947 questions. Hello, Internet land. Have you seen that I'm trying to be hip and way younger than I probably am? I am 147 years of age. Yes, they wheel me out just to do videos every now and again. So what is a function? Those of you into Fortnite, and I haven't yet played, people tell me it's really addictive. I don't know how. I've got a PS4, it's in a box. Need to sort that out. But people say to me, Fortnite is a great computer program, and this, funnily enough here, could be a part of a function used in Fortnite. Highly unlikely, but this here is a computer function. What is a computer function? Well, it's a section of code that can be used over and over again. Obviously, we don't want to keep writing the same thing. Imagine writing an essay where you had the same 14 sentences. Well, you'd probably turn around and write the sentence at the top of your essay and just keep referring to that one sentence rather than write it over and over again. Or maybe just a reference, for example. Oh, that's a much better idea. But it's got nothing to do with what we're talking about in mathematics. I just wanted to sort of talk about Fortnite for a moment. Functions in mathematics are much easier than computer functions, and to be honest with you, you have been using them for the last few years, probably without even knowing it. So, it's an important thing to know here that a function, and this is a definition, I don't use them very often, is a relation, and a relation, if you remember, is just some form of equation. Y equals 3x plus 2, for example, is a relation. It is relating x values to y values, such that for every x value, there is only one y value, all right? In other words, a function cannot contain two different ordered pairs. What is an ordered pair? It's just a coordinate with the same first coordinate. So you can't have the same first coordinate. So which of the following graphs are functions? Right, oh, that's an interesting question. Well, there's a really simple trick, and it's here. It's called a quick test. And it's called the vertical line test. And a graph is a function if you can draw a vertical line through it and it only cuts the graph once. So if I draw a vertical line through this circle, obviously it cuts here and it cuts here. So there are two y values for the same x value. That is not a function. So we'll write the word function and then cross it through. Whereas if I draw a vertical line anywhere through this particular function, or that particular graph or relation, I'm happy to say that in this situation, that is a function. So the vertical line test is really important. All right. Now, they use a lot in MaffsGuru 4, and it is critically important that you understand now what a function is. All right. Now, notation, and more notation. As is normally in mathematics in Australia, there seems to be a conspiracy. Actually, that's probably true in more and more worlds. There is a guy who sits in an office in this place, I swear, who basically is paid to come up with 20 different ways to call something the same thing. All right, so calculus, differentiation. You look at multiplication, you've got product, you've got times. I'm sure there's others. Yeah, why can't we just use one thing? All right, and that's the problem with maths. Because we've got so many different ways of talking about the same thing, it seems to confuse everybody. But hopefully not in my classroom. So first things first, stuff you just need to know. Image. Wording is basically the y value. So if you're ever asked to find the image, you're being asked to find the y value. If you're asked to find the pre-image, it's the x value. Again, this is just notation. It's just stuff that you need to learn, put somewhere, and just try and remember it. Just in case there's an exam question that can actually that will trick you up. Now, there's a number of different ways that relations can be expressed, right? I know it says functions here. I'm getting nervous about using the word function. So y equals 3x plus 4. That's standard. We've been using that since what, year 9? Then we get to this f of x business. So that's more sort of what, year 11-y stuff. F of x is exactly the same thing. This here, exactly the same thing. This is just a different notation saying a set of ordered pairs is created using this type of notation. We can write it in full-on function notation where we're saying, well, we're now going to give the domain and codomain. Remember, this value here is not the range. So the domain and the codomain, which says we have got a function here where all real values are possible, or we can actually limit our function. All right? So in this situation, we're turning around saying, well, while we've got the function x squared minus 3, we're actually going to be only interested in the section that goes between 0 and 4, which includes 0. So the square bracket includes the 0, but doesn't include the 4, right? We need to know all of this type of stuff. But I suppose it's interesting about limiting the domains. Why do we want to limit the domains? Well, a lot of it is used in methods 3 and 4, right? We limit domains muchly with regards to inverse functions when we take inverse functions, and an inverse function can only be, or a function can only have an inverse if it's what we call one-to-one. And to make it a one-to-one, you have to limit domains. And is this making any sense to you? Nah, well, don't worry about it. It will soon, right? So this notation, this function notation is really, really important. I've just talked about restricting a function. So there are other important notations that you need to be aware of. We're already happy with this one. We know that this one means a function is all real values. So that first there is my domain, remember? This one here is my codomain. What's a codomain? No idea. Do I care? Not really. Will I care at university? Absolutely. Here, not really. Please, again, don't think that's the range. It does not mean that that is the range. Here, this is important. Again, ignoring the mapped onto R, this here means all positive real values and or including 0 or 0. So this now says, basically, I'm only looking at the values of the graph, for example, if that was a quadratic, from 0 and onwards. If I just had R plus, it wouldn't include the value of 0. So I'd probably put a circle there to say I'm not including the 0. Here, this basically says all real values except 2. So I might have a function, for example, 1 over x minus 2, where the value of 2 just isn't going to be possible. If you think about it, if I put 2 in there, I get 1 divided by 0, and anything divided by 0 basically means it's undefined or impossible. All right, so we need to make sure that we understand and can write in function notation. Remember, functions are always denoted with lowercase letters. So, almost the end of this one. Wow, that was quick. It's really important to understand what f of 2 and f of 10 means. Remember, if you have f of x is equal to 3x plus 2, just writing f of 2, what do you notice? Well, the x has been replaced by the number 2, and that's exactly what it's trying to do. This is just another way of saying substitute x is equal to 2. So I'd have 3 times 2 plus 2, which would be 8. Please, please, you need to know this, right? It's so, so important, all right? And for some reason, I decided that we were going to have some reference to crazy. And Albert Einstein, I think, is phenomenal in the sense of insanity is doing the same thing over and over again and expecting different results. As far as I'm concerned, that should be a clinical definition. Okay, that was a brief skip through the idea of functions. What was the headline from it? A function is a graph where you can draw a vertical line through it and it only cuts the graph once. All right, thanks very much for your time. Look forward to seeing you again. It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So, if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right? Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. All right, well, you have an awesome day, and I look forward to seeing you again.